In this video, I will be going over the various different lighting options that is available in Blender. So right now I have the monkey head and a backdrop. If you are doing the lighting lesson, then I'll be giving you a task to create your own backdrop and a model so you can do the 3-point lighting task as well. What I'm going to do is I'm going to go to add and you'll see sort of like near the bottom area, you have the light option and there are 4 different types of light. So I'm going to go through each one of these. So first off, we have the point light. The point light is a omnidirectional light. Think of it like a light bulb. So like a light bulb having sort of like an area of effect that kind of like gives like a nice sort of lighting in a certain area, depending on how strong it is. But right now you can see that we're not actually seeing the light itself. We're not seeing any effect on our model as I move it around. Now, why is that? That's because we are currently in the solid viewport shading mode. But if we go to this option here, which you may have used before, this is called ren- the rendered um, viewport shading option. Essentially, what this does is that it calculates everything. So it will show off your materials that you've assigned to your models, as well as showcasing the lighting and how it looks. You'll notice that as I move my camera around, you get this weird sort of artifacting going on. That's because Blender needs a bit of time to kind of compute um, where the camera is at that point. So if I move this over here, you see a bit of artifacting, but once I lay it still, Blender can recalculate, okay, this is where the camera is. I can now recompute the lighting information. So you can kind of see like a nice preview of what it would look like if I was to render this out as an image or as a video, for instance. So with my point light selected, um, if you go to this little light bulb icon here, you'll see this is called the object data properties, and we have various different properties that we can affect this light. So the first one I'm going to do is power. So you can see it says W next to it. It's because it's kind of based off wattage. So if I put this to like say 50, you can see the light has increased its intensity. If I put it to 100, obviously it gets stronger as well. And you can see obviously you get some shadows as well, and some shadows on the monkey head. I can change the color as well, so I can go to say maybe like a orange here to kind of make it feel a bit more warmer. Go to blue, for instance, make it a bit of a colder look to the scene. Put it back to white for now. So with the point light, it is only affected by its location. So you see, as I move it around in the different axes, the light is changing depending on the position of the point light. So you see, if I put it right above the monkey head, shadows are pointing downwards because that's where the lighting is. Move it this way, the shadows kind of moving towards the back. Put it towards the ground, you can see like basically the area of effect that this has. I'm just going to put it over here for now. So we have power that increases and decreases the amount of light that is emitting from the point light, the color. We also have radius as well. So if I increase this, so just pay attention to the shadows. You'll see that when I increase the radius, you have this little circle here, and the shadows have kind of gone a little bit faded. That's because the radius impacts the fallout on the shadows, essentially. So the size of the radius impacts the effect it has on the shadows. So if I put it back to 0, you'll see we have these very sharp shadows. Might be good if you're doing like sort of like a stylized gamer, for instance, but not really great if you're kind of doing something more realistic. Like look at your shadows when you're kind of moving around in the daytime. They don't look this sharp. Depending if it's like a very intense light. There usually is like a little bit of a soft fallout as it kind of fades away. So you can kind of increase the radius and you can kind of create that effect there. So you see you've got this nice sort of more subtle shadows there as well. So I'm going to change this to the sun. So you can see now it's quite intense right now. It's gone to 100. I need to put that down to say 1. I'll put it to 2. The strength is essentially the same as power. So it's the strength of the actual sun. This is basically simulating like the sun in the center of our solar system, essentially. But you can see as I move it up and down, left and right, the lighting isn't really changing. Like the direction of it isn't changing. That's because it's all based on its rotation. So if I press rotate here and just rotate this around, you can see that the lighting and the shadows are being affected because it's all based off of the rotation. So again, we can change the color. We also have the angle. So it's, well, as it says here, it's the angular diameter of the sun as seen from the Earth. So it does sort of like a similar thing as the radius on the point light. So you can see the shadows are getting a bit more subtle. If I put it to 0, it'll be quite intense. Put it down to like say 0.15. See, it's a little bit more softer now. If I put it like say 1 to get sort of soft effect onto it there. We also have spotlight. Now this is affected by both the location and its rotation, because obviously you can see here, if you've ever been to like the theater, for instance, like watch a play or anything, the spotlight's always there. Maybe if you've gone to like say to a music concert, spotlights are there to kind of like focus the light on a particular area. So I can rotate this. Let's just rotate this a little bit towards the monkey. I'm moving this around terribly. And I'll just put this back to white for now. So I'm going to increase this to say 20, and you can see that there is a little bit of a shadow here. I might put it to 50 so it's a bit more obvious. Actually, let's go to 100. There we go. So similar to the point light, power, color, they're pretty much standard. You also have the radius as well. So again, you can impact, the fallout on the shadows. You can see it's a lot more subtle there. Put that back to 0. But at the bottom here, we have the beam shape. So we can change the size of the spotlight itself. So right now it's at 45, but I can increase it, and you can see obviously it's getting wider, which means that the light itself is getting wider. We've got the blend as well, so the softness of the spotlight edge, and I can kind of increase this number here. See this gets smaller, and you can see that the fallout around the actual spotlight itself has become a little bit more softer. Put it there to 0, you can see it's very sharp. Again, try to do something a bit more subtle, like that. And lastly, we have an area light. And an area light is essentially, if you ever hover over these, it does tell you like a quick, brief description. So it's a directional area light source. So essentially, it's just like. And lastly, we have the area light. So the area light simulates light originating from a surface, like an emitter, for instance. So if you can use like say like a TV screen, or like say like a neon light as an example. So it's all kind of based off the shape itself. I'm just gonna put these to 0, and then yeah, let's move this to 90 degrees and just move it towards the front here. So you can see we have this square. I'm just going to put it over here for now. Go back to the data properties. Again, power, color, that's all pretty much the same. Just for fun, I'm just going to put it green. Actually, that's probably that's too green. Let's go purple. So what I can do here is I can actually increase the size of the square itself, so you can see like how the lighting is affected by that. So if I kind of make it a bit smaller, you can see the shadows are getting a little bit more harder, a bit softer, kind of that fallout there. But I can also change the shape of this as well. So with a square, obviously it's going to say square. But what if I want like say like a rectangle, for instance? Well, I can change it to a rectangle, and so I can impact the X and Y sizes. So if I want to say, okay, I want this to be longer, click and drag, give it more of a longer reach, for instance. Or if I want to make it higher, for instance, or smaller, I can do so. And you've got a few options. You have like say a disc, which is basically a circle. And again, like you can't really change the X or Y specifically because it keeps it to like the basic circle shape. But you can also change it into like an ellipse where you actually can increase and decrease the X and Y as well. Okay, so those are the different lighting options. Now, what if we want to render this out? Maybe we're like, okay, I want to take an image of this and save it somewhere. So if I press F12, you'll see that it creates a render of our image. So this here, I can actually save out. I can go to image, and then once it's fully rendered, image save. And I can save it out as like a PNG or a JPEG. So you can see here, I can save it, to whatever I want it to be. Now, it all depends on the angle and the location of your camera. So if I go back, for instance, you can see that when I press F12, it's not rendering this particular viewport. What it does is it renders an image based on your camera. So if I press 0 on my number lock section on my keyboard, you can see I can switch between the perspective view and what I can see on my camera. So if you want to make some really cool renders and images, you want to make sure that you're placing your camera in really nice angles to make a really cool looking screenshot. And then pressing F12 will render it. Now, depending on your render settings, it can take maybe like 20 seconds, 30 seconds. In this case, this might take about a minute to fully render. Now, depending how complex your scene is, there can be loads of lights and sort of maybe physics or other things going on in your scene, which means that it will take Blender a little bit longer to render out an image. So you have various different sort of render options that you can kind of play with. If you press the render properties options here, you can actually change the render engine. So essentially that is how Blender computes and interprets lighting information. So obviously, like say how cameras, reflect or refract lighting information. There are different types of options that are available. So there is Eevee, for instance, which is Blender's sort of real-time engine. It's meant to be quite speedy and interactive for you to kind of create some really nice renders. So if I press F12 right now, there we go. We've got like a very quick render from Blender. And we have sort of various different options as well. So in Eevee, so I can press ambient occlusion, and you'll see that there is some soft shadowing that happens. Ambient occlusion is basically sort of indirect lighting and shadow information, essentially. Pretty much in all the render options, you have various different um, features and functionalities that you can play with. They can be quite complex. We're not going to kind of go into it essentially right now, but I will link to a video that kind of goes into in depth as to like what you can do with Eevee or with cycles, for instance. Now, if you are using the cycles option, lighting will change depending on the different render engines. So you can see right now this is on cycles. If I go to Eevee, it's a bit softer, for instance. It's not as intense compared to cycles. You can see that it's got a lot more intensity. So depending on your render engine, you might have to adapt or tweak your lighting settings. Sometimes by default on some of the computers, it is set to cycles. What I would advise to do is to change the device option. So by default, it's sometimes set to CPU. You don't want it to be on CPU. You want it to be on GPU. You want it to use the actual graphics card in the machines because they're pretty high power, high spec graphics cards. That way, it won't take as long to fully render out an image from Blender. I would advise as well to go to Edit, Preferences, Systems, and then where it says Cycles Render Devices, change to either Coda or Optics because these are uh, um, render devices specifically for NVIDIA. If you have an AMD uh, GPU, then these are the ones that you would have to go for. But it will be for the college, it'll be one of these ones. That way, you can actually kind of render out an image. Press F12 within, like say, 10 seconds or so. You also have output options as well, so you can actually change the resolution on your camera. So if you want to take a nice screenshot at say 1080p, for instance, or 1920 by 1080, so you've got like a nice 1080p image there. You can also change it to like say like a 2K or a 4K image if you know what the image output is. You can change the file format here. The outputs are where you're going to save this image. If you click on the folder icon, you can save it like say downloads, etc.